All right. So today we are going to be talking about sampling. But before we get into sampling, I just want to have two slides that kind of sums up Wednesday's class. Because I know there's a lot of information and I went over it relatively fast. But so on these next two slides, I have some key points that you should know for quizzes and exams. So we talked about the 5 guiding ethical principles. So make sure that you know what the principles are and how we put them into practice. So things like informed consent. What's the deal with deception studies? Are they okay? How do we go about doing them? How do we ensure that participation is voluntary and that we are not pressuring our participants to take our study and continue on with the study? So yeah, know these 5 guiding ethical principles, know their definitions, know some examples of them, be able to identify if I gave you a non-ethical description of a study, tell me what the problem is with it, and then be able to put it into practice. And then we kind of switched gears and we talked about citations. I have the really essential information here. So with in-text cite, so we talked about 2 different ones, right? We talked about in-text citations as well as the reference page. So for in-text citations, if there's 1 to 2 authors, pretty easy. You just use both authors' last names, right? Either at the beginning, which you should limit your use of, or at the end. Then if there's 3+ authors, you just use the first author's name and then like et al. And then the year. And then the reference page, not going to go into it. Make sure you know how to do a reference page. Like I say right here, use the cite feature in EBSCOhost. Incredibly useful feature. You can just copy paste it into your page and do a couple minor edits like changing the DOI to be the proper format. You'll probably, depending on how you paste on the word, you'll probably have to re-italicize the journal title and the volume number, and then do some indentation, and then maybe look at the capitalization, because just the first word capitalizes, but sometimes on EBSCOhost, they'll capitalize like every single word or every single letter. So make sure that you make the changes that you need. Go back to the PowerPoint if you need the more specifics of how to do a citation. I will say that, so for your next assignment number 3, I've been pretty lenient on grading for the assignment 1, assignment 2, and the first exam's essay questions. I've been pretty lenient. However, for things like assignment number 3 with the citations, I'm not as lenient because the answers are out there. It's more about effort now, and I appreciate effort. So, if you make an effort to do proper APA 7 format for all your citations, but, maybe say there's a couple mistakes here and there, your grade will reflect that. It'll be a good grade. If you just post like that bad example I showed last class, where like every citation was a different like format, none of it was APA 7, you're gonna get like 5 out of 15, like a really poor grade on that. So put effort into this. Doing these citations, not that hard, especially if you use the EBSCOhost, because it gives you a majority of it already. You just have to make a couple minor tweaks. Yeah, so I just wanted to create these two slides just as the key important information, and maybe to help guide you into what you really should be focusing on. I'm going to try to do this every Friday, or maybe after every class, just depending on how much time I have, but hopefully this was useful. All right, so let's jump into sampling. Hopefully you had a chance to look at the pre-lecture, because these next couple of questions are going to be incredibly easy if you looked at the pre-lecture. But can someone tell me what the difference is? So maybe definitions of population and sample, and what the difference is between the two. Anybody? What's a population and what's a sample? Yeah, okay. So someone in chat said population equals the group you want to study, and sample equals a selection of people from the population. Yeah, your population is just this big group of people who you want to study and you want your findings to generalize to. And we'll get into what generalize means. But yeah, a sample is a subset of that population, right? Obviously, we can't study every adolescent in the United States, so we have to get a subset or a sample of that population. So someone tell me, kind of already answered it, just use the uh, unmute yourself and speak. But what is sampling? Why does it need to be done, slash why do we do it, and why is it important? You can answer one of these three, or you can answer all three of these questions if you want. So what is sampling? Why do we do it, and why is it important? Just unmute yourself and then you can speak. No one? No one knows what sampling is? All
I
right.
think sampling is the process that researchers go through to select the participants.
Yep, perfect. Yep, sampling is literally just how you get your sample. Yeah, none of these are trick questions. Good job, Justin. So anyone else or Justin, you can answer, why do we do it? Why do we find a sample?
Because like you said, we can't test like everybody. So we need to find like a specific smaller group of people that it would be possible to test.
Perfect, right? Yeah, we can't sample everyone in a population. Um, or we typically can't assess everyone in a population. So we need a small portion of that. We need a sample. And why is it important? Why is it important to get a good sample? I guess. Let me rephrase that.
I think
So
the
that,
better. Oh, sorry, you can go.
I was just gonna say that you can generalize if you
Perfect.
have a sample with more variant in people, you can generalize it.
Yeah,
Sorry, I didn't mean to interrupt you though.
that was perfect, Seneca. Yeah, we want to have a good representative sample because we'll be able to generalize our findings. So let's jump into that. So sampling is, like we said, the process by which participants are chosen to participate in our study. It's how we choose our participants. And we want to sample in a way that allows us to make meaningful conclusions about that population. Just like what Seneca said and the people that participated, Justin and Audrey. Thank you so much. So this brings up the idea of representativeness, or we want a sample that accurately reflects our population of interest and whatever demographics that we think are important, like age, gender, race, education, or religion. And there's any type of variable you can think of. We want them to match. So here's an example. So let's say that I wanted to understand, or I wanted to know and do a report on what the average West Virginian opinion of Joe Biden is, right? We just want to know, what is the average West Virginian's opinion of Joe Biden. But let's say I collect my sample and my sample turns out to be 90, I collect 100 participants and 90 of them are Asian American. Well, that's a problem, right? I would assume that majority of West Virginians are not Asian Americans. So our sample doesn't reflect the population. Our population is West Virginians. So if we would find out from my study that the average out of 10, like the average like of Joe Biden is 8 out of 10. That's what the average participant said. And I would do a report saying, hey, typical West Virginians like Joe Biden, right? The average West Virginian said 8 out of 10. That's not true because my sample doesn't reflect my population. So our goal is to obtain a good representative sample. A good representative sample will lead to accurate, unbiased estimates of population characteristics, and it will allow us to generalize results from the sample to the population. So the idea of generalization. So you want your sample to represent the population. So let me kind of break down these two sub bullet points. They're not bullets, but these two bullet points underneath the representative sample. So this first one. So before we even analyze our data, right? We collect our 100 participants, and let's say we have a good representative sample, right? We took all the steps, and we'll talk about later today how to go about this, how to get a good representative sample. But let's say that we have a good one. It would allow us, before we even analyze our results, to be confident that, hey, this data that we collected from these 100 people represents our population. So let's keep on this idea of West Virginia. You know, if I collect a good representative sample, I'll be able to say, hey, these 100 participants accurately reflect the average West Virginian. Then I analyze my data. I find out that majority of people like Joe Biden. Then it'll allow us to generalize results from the sample to the population. Then I could say, hey, the average West Virginian likes Joe Biden. You notice I'm not saying, you know, my average sample or the people that I sampled like Joe Biden. No, I'm saying, hey, the average West Virginian. I'm taking my results and applying them to my population. So let's go to the next slide and we'll talk a little bit more about generalization. So generalizability is the degree to which results from the sample apply to your population of interest. The more representative your sample, the more generalizable your findings. So here's another example. Let's say I am doing a study like my research. My research is all about social media use and well-being in adolescents. So let's say I do I collect 100 adolescents and I find out that my sample on average spends about 4 hours of time on social media a day. However, I know that the population average is about 2.5 hours. This isn't accurate, by the way. I just came up with this. I didn't have time to look it up. But let's say the average adolescent in America spends 2.5 hours on social media. But the average adolescent in my sample spends 4 hours. And so let's say I'm doing a study on social media addiction and depression. Whatever results I come up with, well, it doesn't apply to the average adolescent, right? It only applies to adolescents who use above average levels of social media use. So I don't have a representative sample because my sample uses social media way more than the average adolescent. So therefore, if I'm doing a social media study, I would probably, or I definitely want adolescents to use the average amount of social media. So like this says, my sample is not representative of the population. Therefore, any effects that I find, let's say, you know, I'm doing increased social media addiction is related to increased depression. Any results that I find may not apply to adolescents in general. They probably only apply to adolescents who use above average levels of social media. So I need to make sure my sample it represents the population. Because if it does, I can generalize my findings. Can you have a sample that is representative of a population, but you can't generalize the results? You might have to speak, you might have to unmute yourself and explain a little bit more. Yeah, can you unmute yourself and explain yourself a little bit from that question?
Well, I was just thinking like the more representativeness you have, the more you can generalize it. But I wasn't sure if there was just like cases where you have representativeness, but you can't generalize it, or if there's just not any of those scenarios.
Um, that situation may occur where you can't generalize it, but it wouldn't be a result of your sample. It might be for some other reason. So when I say that you can, whenever you say that you can generalize it more, it's not that you can generalize it more. It's just that you can have more confidence that the results that you found would be found in the general population. It's not, so that's what we mean by you can generalize it more. It's just you're more confident that your results are accurate.
Okay, that makes sense. Thank you.
Yeah, and so, yeah, so if you have a representative sample, you can be, you know, really confident. If you have a really, really good representative sample, like imagine every key demographic that you care about, it's all the same. You can be very confident that the results that you found would apply to everyone in that population. That was a good question, though. Are there any other questions about representativeness and generalizability before we jump more into how to go about doing sampling? Oh, okay, okay. I have a question to throw out to you. Use the direct message chat feature in the chat section to let me know you use it. So we want a representative sample of 100 WVU undergrad students. Which of the following sampling methods would lead to the most representative sample? So A, I just randomly choose 100 students from this class. This is typically done when we have, during the regular fall and spring semester when we have more than 25 students. B, randomly choose 100 undergraduate classes and then randomly select one student for each class. C, I stand in front of the mountain layer at 9 a.m. I select the first 100 students that walk by. Or D, obtain an alphabetical list of all WVU students, select the first 100 students from the list. So go ahead and the direct message, tell me which one you think is the best way to get a representative sample. All right, yeah, good job. I mean, everyone who's responded so far has said B, which is the correct answer. Good job. That is the best way out of these ways listed to get a more representative sample. Can someone tell me why A wouldn't be the best way to go about getting participants? Why would that not lead to a representative sample of WVU students?
I thought because we are all in a psychology class, so it's not very like generalized.
Yeah, good. So you are all, I think for the most part, mostly psychology majors and maybe one or two other majors thrown in. You're all most likely during typical semesters, sophomores with a few juniors sprinkled in and maybe a freshman or two. So you're mostly sophomores, I'm assuming. And you're all psych majors. So these, psych majors may differ in how they think about things, right? Than let's say engineer majors. Or humanities people may think differently on certain topics than non-humanities majors. Sophomores may think differently than seniors or super seniors. Yeah, and then so I'm just going to go through the rest for the sake of time. So think about C. Think about the people who are around the mountain layer at 9 a.m. I know for sure that I'm not going to be around the mountain layer at 9 a.m. I'm probably not going to be in the mountain layer at all, but definitely not at 9 o'clock in the morning. People who are around the mountain layer at 9 a.m. are probably freshmen or earlier, right, who have classes on campus at that time. The mountain layer is downtown. Downtown differs from Evansdale on the type of students who are on each one, right? Potentially, different majors on different campuses. And morning people. I know I'm not a morning person, so people who have morning classes may differ from people who don't like having morning classes. So there's a lot of differences that may occur from people who are going to be around the mountain layer at 9 a.m. And then D, this one's a little tricky, but let me break it down. So names may be influenced by culture, right? So think about something like a typical Asian, like what's the most common Asian surname? I believe it's like Kim. So there's a lot of K's out there. Think about the like what's the most common name in the world is I think it's something like Mohammed. So if so people who are maybe of that descent might not have names up at A's and B's and C's, so they might not be included, or actually it'd be all A's if we're just listing off all WVU students. There's more than 100 A's. So maybe people who have an A last name that starts with an A may differ than someone who is later down in the alphabet. But yeah, so B is the best way. So let's jump into the different ways of sampling. So we're going to talk about all of these today, but all seven of these can be broken up into two categories. We have probability sampling and non-probability sampling. So we're going to go into each one of these, but just know that probability sampling is more likely to lead to a representative sample. So if you do one of these 4 ways for probabilities under probability sampling, you're more likely to have a good representative sample. However, this is difficult, well, difficult to achieve, but probability sampling is difficult to practice because it is time consuming and costly compared to non-probability sampling. And as we go through each example, you'll see why probability sampling is a little bit harder to achieve. So non-probability sampling is less likely to lead to a representative sample. There's things that you can do to better your chances of getting a representative sample under non-probability sampling, but it is easier to achieve, and a lot of research uses non-probability sampling. So let's jump into the different types. We're going to start off with probability sampling. So what is probability sampling? It is selecting a sample such that every member of that population has a defined and typically equal chance of being included in your sample. So everyone in that population has an equal chance of participating in your study or being offered to participate in your study. Because remember, you can always offer a participant, hey, do you want to be in my study? And they can say no. And then obviously you can't force them to be in the study. So everyone in your population has a chance, an equal chance of being included in your survey. So let's jump into different types of probability sampling. We have simple random sampling. And this is just what it sounds. Every member of the population has an equal chance of being selected for the study. Simple as that. And here's how you would go about doing it. You need to identify all members of the population of interest. You then assign everyone in the population a number, and then using a random number generator to choose participants until the desired sample is reached. So let's say I wanted a sample of 10 participants. And let's say I'm just going to use the 20 people who are currently in this room right now. In this class right now, excuse me. So I've identified all the members of the population, right? Let's say my research question is, I want to know what the average PSYC 203 perception of Joe Biden is. Let's just stick with that. Well, I've identified all the members, all 20 of you. I assign every one of you a number, and then using a random number generator, I select 10 participants and I ask you, hey, do you want to be my study? So you can see how this would work when I know my population, but this obviously wouldn't work, let's say if I was doing something like adolescents, right? If I wanted to study social media addiction and well-being in adolescents, I obviously don't know every adolescent in the US, right? This is just unreasonable. So some of these, they're not designs, but some of these ways of sampling are only feasible in certain situations. And for simple random sampling, it's when you know everyone in your population. So this is a really basic way of ensuring that everyone has an equal chance of being in the study. But sometimes you want to make sure that your sample, you want to make sure that you have systematic representation of different subpopulations in your sample. And let me use an example because I think this will, or let me go to the procedure and then an example. So how you go about doing this is you divide the population into 2+ strata, it's called strata, but these are essentially the subgroups based on some common characteristic. So let's say I'm interested in, I want to know gender differences, or I just want to make sure that I have an equal number of males and females. Well, I could make sure that, so I divide my population into 2 strata. So I have my list of WVU students and I separate them into males and females. Then I randomly sample from each stratum or each category or group by selecting an equal number of participants or in proportion population membership, which we'll get to that second point in the next slide. So let's say I want to sample 100 WVU students and I get a list of all WVU students from the administration. And I'm going to separate them into males and females, and I want to make sure I have 50 males and 50 females. So that would be an example of stratified random sampling. I'm still random sampling, right? Everyone still has an equal chance of being in my study. However, I'm going to make sure that I have an equal amount of males and females. There's also this other idea of the last portion of the sentence that says in proportion to population membership. And let me show you what that means. So let's say that I want to do a study of of adults in the US. Let's still stick with the social media and well-being. But I'm not limiting it to adolescents. I'm limiting it to 20 plus. So anyone from 20 to, to death. Well, actually, let's stick with this Joe Biden example. With this political example. Let's say I collect 200 participants and they all turn out to be, or not all, but let's say 150 of those participants are 85 plus, right? They're 85 years old or older. Well, that doesn't really represent the US population, right? The US adult population. So I do my study, there's 150 85-year-olds, and the rest of the 50 participants are, other ages. And I find out that it's once again, it's an 8 out of 10, or how much someone likes Joe Biden. And I say, hey, the average American likes Joe Biden. Well, no, because my sample doesn't represent the US population age characteristics, right? It was mostly older people. And maybe older people are more likely to be, to like Joe Biden, or they're more likely to be Democrat, or, because they are older, they differ than the average younger American. So one of the things I can do is I want to make sure that I have an equal representation, but it's in proportion. So I know that the age group 20 to 24 is about 9.4% of the population. So therefore, I want to make sure that 9.4, or roughly, right, about 10% of my sample is people from the ages of 20 to 24. So then in my sample, I'll have about 19, 20 to 24-year-olds. So I can keep on collecting data until I fill up my quota, until I fill up my, my 19, 20 to 24-year-olds, my 40, 25 to 34-year-olds, my 4, 85 plus year olds. So I'm filling up my quota. Everyone still has an equal chance of participating in my study, but I'm hitting my quota of age. Think about it and this might come up a little bit later, but think about it in terms of WVU, right? So I have my population of WVU students, but I want to make sure I have an equal amount of freshmen, sophomore, junior, or senior. So I can make it equal. Let's go back here. I can make it equal where I have 25 freshmen, 25 sophomore, 25 junior, 25 seniors, or I could figure out, okay, well, at WVU, what's the percentage of freshmen? Maybe it's 30% freshmen. So therefore, I want to make sure 30% of my sample is freshmen. Doing this, when strata are well defined, this is one of the best techniques to achieve a representative sample, when you are making sure that you fill up your quota of whatever characteristics you care about. Any questions so far on stratified random sampling or simple random sampling? Let's go to the next one, cluster sampling. So this is where you sample a group or cluster of individuals. And this makes a lot more sense with an example. So let's say I wanted to do a study on all school children in West Virginia. So let's just say all high schoolers in West Virginia. Well, I clearly can't get a list of every high schooler in West Virginia, right? There's no, that list doesn't exist. And if I were to go to each high school, I don't even know how many high schools there are, but let's say there's a lot of high schools in West Virginia. But even then, I wouldn't be, even if I approached them, they wouldn't give me a list of every participant in their contact, or every high schooler in their contact information. So that isn't feasible. Well, what I can do is obtain a list of all high schools in West Virginia, and then choose a random sample of schools. So maybe, I'll just, put all the high schools in a hat and just pull out the high schools, or use a random number generator, or however you randomly select. So each school has a equal chance of being pulled out of the hat. Just use that phrasing, pulled out of the hat. So each school has an equal chance of being chosen. And then I randomly sample high schoolers from each chosen school. So this is a really good option when true random sampling is impractical. So this is an example of cluster sampling. And typically when you look up examples of cluster sampling, it's always about schools. Because this is a really common way for researchers whenever they are trying to look at high schoolers or just all school children in a state. Does that make sense with cluster sampling? You identify high schools or you identify clusters, you randomly select from those clusters, and then you randomly select from those participants from that chosen cluster. And I believe this is the last one for probability sampling, and this is called systematic sampling, but it looks a little bit different from the rest of them that I talked about. So this is where you sample every nth individual from the population from whom you come into contact. So let me show you two examples. So let's say you wanted to see how satisfied Kroger customers are. And you could, in theory, stand outside of Kroger and ask every single person, but that's really time consuming. You might not have the resources to do that. So this is where you stand. So systematic sampling would be you stand outside the door, and every 10th person who walks out that door, you ask them to be in your study, in your really short study. So there's a key difference between doing it this way and the other three ways that I talked about. We don't have a list of people who are going to shop at Kroger, right? I don't show up, let's say I want to do my study at 1 p.m. I don't show up at 1 p.m. and Kroger can't give me a list of everyone who's going to shop at Kroger for the next 3 hours, right? It's just impossible. But I can still ensure that everyone has an equal chance of participating by asking every 10th person or every 5th person or however many, every blank amount, every nth person. Here's another example. So you want to study alcohol consumption among people who come into the ER. So you go to Ruby or you go to Mon, whatever, and you sit in the ER, and everyone who comes in with an alcohol consumption, you're interested in that population. So you could study every 8th person who comes in the ER until your desired sample size is reached. And this is the same principle. You don't have a list of everyone who's going to come into the ER because of overconsumption of alcohol, right? That's just impossible. It doesn't exist. You can't predict the future. So you need to use this systematic sampling to ensure that every person who comes in, your population, has an equal chance of participating. That's the whole point of probability sampling, right? If we go back to that probability sampling definition, it's that every member of your population has an equal chance at participating. So this is one of the ways to do it when you don't have a list of all your participants. Are there any questions about probability sampling before we jump into non-probability sampling? All right, let's jump into non-probability sampling. So this is where the probability that any particular individual in your population will be chosen is undefined. We're not sure what the probability is. The advantage of this is that it's much easier and much more cost-effective than the probability sampling. But the disadvantage is that your sample may differ systematically from your population of interest. And this is a problem when it comes to things like generalization. So there is an advantage, easier, but you're more likely to have systematic differences. So let's talk about 3 different ways of non-probability sampling. And this one is, I think, the most common way of getting participants in most psychological research. And it's called convenience sampling. And it is what it sounds. You're sampling just out of convenience. This is what is the most easiest. So you sample from your accessible population. What do I have available to me? And a lot of research, right? It's undergrads at the university that the research is being conducted at. It's just the accessible population that you have. So let's say, here's an example. We want a sample of WVU undergraduate students. I could just use this class, right? You probably, even though we talked about how you may differ because you are psych majors, you may differ than the average West Virginia student, you still are a good source to get, the average West Virginia student. You may differ, but you still all are WVU students. So I can still ask you and then generalize those findings, right? But I can't be as confident about my findings than if I did some of the probability sampling. So here's another convenience sampling. You stand in front of the mountain layer at 9 a.m. and then just interview the first 30 undergrads who show up. Another way of convenience sampling is what you're doing for your study, where you just post it on social media and you say, hey, please take my study. It's another way of convenience sampling. So this is probably the one that you're most familiar with. Just who you have available, you ask them. So then there's something called quota sampling, which is getting a little bit more specific, but it's just like stratified random sampling that we talked about a couple minutes ago. So you want to, your sample is created to represent key subsets of the population. So like I said, it's just like stratified random sampling. Remember, going back, this is where we, this is the example of I want only 4 85-year-olds and 19, 20 to 24-year-olds. So here's an example of this. I want to make sure that my sample of WVU students has a an equal number of freshmen, sophomore, juniors, seniors, and super seniors. So what I could do is stand out in front of the mountain layer and interview or try to get, as soon as someone walks by, hey, do you want to take my study? Let's say they say yes. And they're a freshman. All right, so I check off freshmen. I have 20, now I need 24 more freshmen. So just every time someone walks by, it's just like that quota sampling. It's just like the stratified random sampling where I need to fill up my quota, but I don't have a list of the participants beforehand. It's just whoever shows up, right? Whoever's walking by, I interview them, all right, they do the study, and I can check off, all right, I need this many more sophomores, this many more juniors, this many more seniors, and so on. So it's convenient sampling, right? Just whoever walks by, but I want to make sure that I have an equal number of whatever, men, men and females, freshmen, sophomore, junior, seniors, race, whatever demographic I'm interested in or I care about. I believe this is the last one, snowball sampling. So this one's really interesting in my opinion. It's not done a lot in psychological research or in certain specific research it is. But this is a sampling method that's used to identify a special population that's difficult to find or reluctant to be identified. So think about things that are illegal, like prostitutes, illegal immigrants, people who are homeless. So I can't just, I could, but I probably wouldn't be that receptive if I walked up to the homeless encampments in Morgantown and was just like, hey, do you want to be in a study? Do you want to be in a study? Probably wouldn't be too well received. Or if I were, to try to find, prostitutes, right? Or people who are working on the streets, probably wouldn't be that well received if I walked up and say, hey, let's assume that she is a prostitute or he, do you want to be in a study? They probably aren't going to be too receptive to that. So in snowball sampling, this is where you identify one member of that population, you gain their trust, right? And I don't mean, in unethical ways, maybe this is someone who wants to help. You enlist that person to help identify other potential participants. So, I go to let's stick with this homeless person, these homeless people example. I find someone who's homeless in Morgantown, you gain their trust, maybe for whatever reason you gain their trust, and then they can help you go to other people in that population, in that homeless population, to help find participants to be in your study. And so in theory, you find one person, they find a couple people, those people find a couple people, right? It's almost like multi-level marketing for research in a sense. But, so this is a good way to get participants in these special populations. So the next few slides are some potential problems and how we can maybe address them. So there's this idea of sampling bias. So this occurs when your sampling procedure favors certain people for certain groups or individuals. This leads to a non-representative sample. So this is always problematic with convenience sampling, right? Let's think about standing outside of the mountain layer at 9 a.m. We talked about this, who are we most likely to get? Well, maybe freshmen, maybe people who aren't on downtown campus, which is, maybe different than Evansdale campus. And maybe they're morning people. So our sample is biased. But it is also potential problematic for random sampling methods, from random sampling methods. There's always a chance that even if it's completely random, that your sample is still biased. So sampling bias is a problem that occurs in any way that you get your sample, but particularly in the convenience sampling and the non-probability sampling methods. So here's some more on sampling bias. So this target population is often a theoretical entity, often without a master list. Think about my research, adolescents. I don't have a list of all adolescents. So yeah, so I like this example at the bottom. So to develop a sample, we rely on something called an accessible population, right? Who do we have available that we can access? However, this accessible population, the sampling frame, may not include everyone, and it may be biased in who it includes. So this is easier to understand with an example. So let's say I wanted to do a study of Morgantown residents and what they think about, I don't know, the bike lanes, the bike lanes going, on the roads, and I want to access, Morgantown residents, people who live in Morgantown. So one of the ways I could go about doing that is use the phone book, right? The phone book is a real thing, it exists. I could go in and I could say, okay, every 10th person, I will contact, call and try to get be in our study, or whatever sampling way you use. Can someone tell me what the problem is of using something like a phone book? And why, if I use a phone book, it may be biased? Sydney?
It's outdated.
Let's say it's most up to date. So let's say we use the 2021 phone book. So it gets rid of that outdated problem. Can someone tell me who isn't in the phone book that lives in Morgantown?
Students who live in the dorms.
Or just students in general? Yeah, most students who, if you don't claim that Morgantown is your like home of residence, right? Even if you like rent an apartment here, unless you claim that you live in Morgantown, you're not going to be in the phone book. So probably 90% of students at WVU are not going to be in that phone book. Therefore, I'm not going to be assessing any WVU students. And WVU students are a large portion of Morgantown, right? So if I use the phone book, I'm already excluding all the West Virginia University students, and that's such a large portion of my population. So right there, my sample is biased because I'm not asking students. There may be other problems with the phone book, like people who don't have a phone, right? If you don't have a phone, you obviously won't be in the phone book. Maybe that might not be a problem for Morgantown, but maybe some more of the more rural areas of West Virginia, that might be a problem. What else? Wealthy people, if you have an unlisted number, right? So because you don't want to be in the phone book. Like I don't know if the basketball coach would be listed in the phone book, because I don't know if you would want your phone number out there, right? And there's those ways to get around that. So my population is Morgantown residents, and I want to use the phone book, but there's problems with that. And if I use that phone book, my sample will be biased. My accessible population may not accurately represent the full population. But so there's also another problem, and that's called non-response bias. So people who agree to participate in the study are often very different from those who don't. So here's an example of the grant that I was just on, where we were, long story short, we were assessing parents and adolescents, and like how kids learn how to regulate emotions. Let's just sum it up like that. So people who participate in the study, like the relationship between the parents and kids, are probably going to be different than people who don't want to participate in the study. I would assume that people who don't want to participate in a study looking at the relationship between parent and child are maybe there's a bunch of reasons why you don't want to participate in the study, but maybe people who don't participate are families who don't have high quality relationships, right? If you're not on good terms with your kid and you have a really rough relationship, you probably don't want to participate in a West Virginia University study that targets, hey, we want to look at the relationship that you have with your kid. For whatever reason, maybe you don't want to come off as being a bad parent. So we're not assessing all parents, I guess, parent-child, dyads. We're assessing only people who want to participate in the study, and these people may differ. So this is the whole idea of non-response bias. People who don't agree to be in a study may differ than people who agree to be in a study. So here's a couple examples. So think about a mail-in survey. Can someone tell me who is most likely to return a mail-in survey? So I mail you a survey through the mail, USPS, and ask you to fill it out and send it back. Who is most likely to return that survey? Just take a guess.
I think it'd be like the older populations.
Yep, for sure. Older adults, who have free time on their hands are going to be more likely to turn that mail-in survey than we are, right? If I were to get one, I would probably just instantly throw it away. Like, I don't care about this. Older adults are more likely to turn these mail-in surveys. So right there, bias, right? By using this mail-in survey option. Even if we would mail it out to we somehow got in cahoots with the US government and we got the US Census information and we sent it out to every American in the US, it still would be biased because we're most likely, because of the way we're trying to get participants through the mail, it's going to be biased. Think about it, if I wanted to do a survey of stress level in college students, and I sent out a survey to every WVU student around, I don't know, midterms or finals or just whenever, who is more likely to turn it back? I'm going to answer it myself. People who are not as stressed, right? Probably people who are really stressed aren't going to want to take time out of their day to do a survey. So therefore, the people who respond back are going to be the less stressed students. And therefore, my sample is going to be biased. So there's all these things as a researcher that you have to think about when you're trying to get participants. There's all these small little things. And even something as simple as like mailing the survey out to everyone, right? You think, oh, that's the best way to do it, right? Email every WVU student and see if they'll take your survey. You still will be biased. You still will be biased because of this non-response bias. Or people who don't respond will differ than people who respond. So there's some solutions to this. You can prevent it by just trying to get as much data as possible, right? So if you need, just get as much data as possible. Even if you only need 100 participants, get 300 if you can. This comes with problems, obviously, right? Maybe more costly, take more time, but it is a way of getting around this non-biased response or non-response bias, excuse me. Another way, which is really hard but incredibly informative, is to obtain data from the non-responders and assess the differences from those who didn't respond, from those who did. So, potentially I have 100 participants, right? Or I email every WVU student and let's just say 50% respond back. I could email that 50% who didn't and say, hey, I know you didn't take this survey. This will only take you like 2 minutes, and ask them a couple questions, maybe relating some key demographics that you think are important for why they didn't answer. And then you can see, hey, do these participants who didn't respond, or they're not participants, did these people who didn't respond differ from those who did on some of these key demographics? Maybe more freshmen didn't respond. Or maybe people who are really stressed didn't respond. So this is often really hard to do because if they didn't want to take your study in the first place, probably not going to be likely to do a follow-up shorter survey, but maybe they are. And maybe you can get, maybe if 500 people didn't respond, you can get 100. And that would be a good portion of that population, of those people who didn't respond. So yeah, so you can assess any differences between non-responders and responders, but this is often difficult to get because non-responders don't want to respond. All right, so these last 2 or 3 slides, looks like we can get out of here early, which is good on a Friday. is the bottom line. So the big key points here. So sampling is a major concern for researchers as it affects what we can reasonably conclude from our data, right? Whenever you write in your discussion about a research study, you're saying, hey, here's what we found, and here, and you apply it to your population. Our goal is always to get as representative a sample as feasibly possible. And so you may be thinking, well, why don't we always just do, the probability sampling methods? Like we said, the disadvantages of those, they're time consuming and they're costly. And it's just not the most effective or feasible depending on your research design. So probability sampling is most likely to create a representative sample. It's best choice when feasible, but like we said, not always feasible, especially if you don't have access to the entire population. It's especially important when doing a descriptive study. We'll talk about descriptive studies next week. And it's less critical for correlational, experimental, and quasi-experimental designs. Once again, we'll get into all of these different designs, I believe, this coming Monday or Wednesday. Non-probability sampling, it's much easier to achieve. It's the acceptable choice when criteria for the unbiased probability sampling can't be met. And we talked about situations when we can't meet that, we can't do that probability sampling. And then you can replicate your study with different samples to generalize those findings. So let's say you can use convenience sampling, right? Let's say I'm doing my research on adolescents, social media, and well-being, and I am limited by who I can access, and that's adolescents in Morgantown, right? I go to the high schools or the middle schools and I assess them. Well, what we can do is maybe I can have someone I collaborate with in California do the same exact study with adolescents in their area. And then maybe my collaborator in Minnesota can do it there as well. So we can replicate the study in all these different samples, and we should hopefully see that all these different samples, the results are all roughly the same. Then we can generalize our findings. All right, that's it. Don't go just yet. Let me show. So that covers probability sampling, or that covers sampling and probability and non-probability. Does anyone have any questions as I get this Qualtrics thing open? WVU Qualtrics. Because I want to show something in regards to the survey. And then we can go. Gotta do this duo. All right. So just look at these top two. This is the exercise, groups 1, 2, and 3, and this is groups 4 and 5 of social media. And we can see after what, 2 days, not even 2 days, we have 235 responses for the groups 1, 2, and 3, and we only have 57 responses for the social media. Not bad. We still have like a week and a half. One thing I'm going to recommend is maybe over the weekend, if you are in groups 1, 2, and 3 at the exercise, if you would like, and you would appreciate it, maybe switch out the links for the social media people, or tell your friends, put in your stories or whatever, hey, take this other survey. This social media one is shorter, so if you want to preface it, if you are in groups 1, 2, and 3, hey, I know I already asked you to take a survey. Take this other one. It's even shorter than the one you took, just so that way we can get more responses. But yeah, 235 is great. That's amazing in 2 days, something like that. So let's just try to get at the social media one as well. So if you're in groups 1, 2, and 3, you can go ahead and take off the link to the exercise survey and maybe put up the social media one just to help out those groups as well. Quiz number 4 is currently open and it will be available to do until Sunday at midnight. Go ahead and take that quiz. Yeah, are there any questions for me about anything in regards to the homework assignment number 3? That is going to be due this coming Monday. Make sure you upload, everything to the assignment folders in the campus. If there's any problems with that, let me know. Yeah, are there any questions for me?